In this lesson, we are graphing quadratic functions. We've already learned now how to graph quadratic functions in standard form, vertex form, and intercept form. So we're basically just putting it all together. There's not really anything new in this lesson except to be able to look at the function that's given and initially determine which form it's in and then find the appropriate information from there. So let's take a look at example 1. Since this is in the form y equals ax squared plus bx plus c, we know this is called standard form. When it's in standard form, to find vertex, we can do the opposite of b over 2 times a. And so negative 2 divided by 2 is a negative 1. To find the y, we use the function and plug a negative 1 in place of x. So when I do negative 1 squared, which is 1, plus 2 times negative 1, which is negative 2, and then negative 8, I get, let me fix that equal sign, negative 9. So our vertex is at negative 1, negative 9. Then the axis of symmetry is x equals negative 1, always a vertical line passing through that vertex. For y-intercept, I just have to look up at the c value, negative 8, so 0, negative 8. That's what I would get if I plug in a 0 anywhere I see an x. And then it asks for the x-intercepts. So when we did standard form, we were not asked for this, but now that we know how to convert from standard form to intercept form, we could do that to find the intercepts. So we can take y equals x squared plus 2x minus 8, plug in a 0 for y, and factor, so what multiplies to negative 8 adds to 2, a 4 and a negative 2, so x plus 4 times x minus 2. Now when I set this equal to 0 and solve, I get x equals negative 4, x equals positive 2, so I have an x-intercept at negative 4, 0, and at 2, 0. So notice what we did here is we converted to intercept form by factoring and then use zero product property to solve. So let's go ahead and graph everything, starting with our vertex, negative 1, negative 9, that would be down here. I'll draw with a dashed line here our axis of symmetry passing through that vertex. Y-intercept of 0, negative 8 would go here. We can reflect that over the axis of symmetry to the other side at negative 2, negative 8. And if we graph the negative 4, 0 and the 2, 0, that gives us 5 points to connect and graph our parabola. So once again, this was in standard form. The only thing new was finding intercepts for the equation in standard form. Next example is in vertex form. We know vertex form is where we have y equals a times x minus h squared plus k. So the vertex is easy to identify. We look at the h and the k, negative 2, negative 3. Y-intercept, we have to do a little bit of work. We have to plug in a 0 for x, so y equals negative 0 plus 2 squared minus 3. So 2 squared is 4, so I have negative 4 minus 3, which is negative 7. So 0, comma, negative 7. Now I'll go ahead and graph the vertex, negative 2, negative 3. Graph the y-intercept at negative 7. If I reflect that over the axis of symmetry, it's 2 away, so I go 2 away on the other side to negative 4, negative 7, and connect. There's the graph of this parabola opening downward. So our domain is all real numbers, negative infinity to positive infinity, and the range starts at negative infinity and goes up to negative 3. And this would be a bracket. So that is example 2. Finally, we have example 3, which is in intercept form. Since we know intercept form looks like this, y equals a times x minus p times x minus q. So the a is 1, and p and q are negative 1 and positive 3. Those are the x-intercepts, negative 1, 0, and positive 3, 0. This form, as I already mentioned, is intercept form or factored form. For the vertex, we can take those intercepts, negative 1 and 3, add them and divide by 2, and 2 divided by 2 is a 1. So the x-coordinate of the vertex is at 1. To get the y-coordinate, I can plug a 1 in for x. So I have 1 plus 1 times 1 minus 3. And that is 2 times negative 2, which is negative 4. So the vertex is 1, negative 4. For the y-intercept, I do the same thing I just did, except instead of where I plugged in a 1 here for x, now I plug in a 0 for x. So y equals 0 plus 1 times 0 minus 3. 1 times negative 3 is negative 3. So 0 comma negative 3 is the y-intercept. Now we can go ahead and graph everything. So vertex is at 1, negative 4. Y-intercept, 0, negative 3. And that can reflect over to 2, negative 3. And we also have x-intercepts at negative 1 and 3. And we have 5 points to connect and graph our parabola. And it should be opening upward, which it is. So that's example 3. What I'm going to go back and highlight here, I'll highlight with, let's use pink. In example 1, which was standard form, what we could see without doing any work is the y-intercept of negative 8. Everything else we had to do a little work to find. In vertex form, you could find the vertex without doing any work. Everything else you have to do a little work to find. And in example 3 with intercept form, you could find the intercepts without doing much work. Everything else you have to do work to find. So each form has its advantages. Like the benefits are the features of the graph that are really easy to recognize right away without doing any work. And then there's other parts that you have to do a little more work to figure out. All right, our last example is given the graph, determine which equation should match each graph and explain. So when I explain, I'm just going to do that out loud here. I'm going to start with the fact that 2 are opening up and 2 are opening down. So we know that in number 1, this would be up. Number 2, this would be down. 3 is up and 4 is down. So let's start with the 2 that are up. We know 1 and 3 must match with A and B. So let's see in number 1, which is in vertex form, we can see that the vertex would be 4, 1. Number 3, which is in intercept form, we know we have intercepts at negative 1, 0 and positive 5, 0. So it looks like number 3 would go with graph A. You can see those intercepts at negative 1, 0 and 5, 0. And graph 1 would go with B because the vertex is at 4, 1. And now we can look at the 2 graphs that are opening downward, C and D, which must match with equations 2 and 4. So equation 2 in intercept form, we have intercepts at negative 5, 0 and positive 1, 0. Negative 5, 0 and positive 1, 0. Looks like this is going to go with D because in C they're both positive intercepts. And if I look at number 4, we have a positive 1, 0, positive 5, 0. That would go with graph C. So there are other ways we could have done these, but I just used the vertex in number 1 since that was vertex form, the intercepts in 2, 3, and 4 since those are all intercept form, and the direction that the parabola was opening, either up and down. And just based on those characteristics, we were able to match all 4 equations with all 4 graphs. All right, so once again to conclude here with this lesson, we did example 1, graphing in standard form, example 2 in vertex form, example 3 in intercept form. And so this lesson was just putting all 3 forms together and reviewing how to graph with each one.